The inelastic collision is the one in which the energy will definitely change and not be saved or conserved after a collision process. Momentum will be conserved at any cost in all types of collision. Now we are going to discuss few real-world inelastic collision examples in detail. The real-world examples are car crashing, mud ball, vehicle crash, clay models, particle collision, falling objects, clapping hands, sliding block. Car crashing. During a car crash, there are possibilities for all the energies to be lost, and that is the form of heat, sound, and sometimes friction. Now let us see the physics behind every action. Now when there is a car crash, the momentum with which it was traveling will now be instantly changing. The car would be traveling at a particular speed. The change in speeds for the car will occur only when the brakes are applied. So when the momentum enhances the speed, there will be a loss of energy in terms of heat while brakes are applied. This is one of the common inelastic collision examples. We shall surely see how this works and what factors aid in making the crash an inelastic collision. There are different aspects that aid in making an inelastic collision. The process goes like this: a car travels at a particular speed, and when the brakes are applied there is a small amount of heat is emitted. This emission is equivalent to the loss of energy in the system. Now that there is a loss of energy in the particular system that has been isolated is considered to be in the process of inelastic collision. Therefore car crash has every possible way to be considered as inelastic collision examples. Mud ball. Basically, a mud ball is a conventional ball that is made out of the mud. So when we use the mud ball is dropped down, it is a known fact that the ball breaks and loses the transformation. The basic behind the ball is that when the ball is dropped down, it instantly gets stuck to the ground, and this is one of the points to remember when we discuss elastic and inelastic collision. Let us see why the mud ball is regarded to be an inelastic collision. When the ball is dropped, as we said earlier, it will undergo a deformation, so there will be a loss of kinetic energy in the process. The potential energy of the ball before the dropping will instantly be conserved into kinetic energy when the motion starts. So the energy will not be conserved after the collision of the ball with the ground. Also, when we talk about the momentum, it will be conserved at any cost because the momentum will increase since the friction is zero, and then the process will be an inelastic collision. When the momentum is conserved but the energy being lost in that process, it is the inelastic one. Vehicle crash. The vehicle crash is one of the easy and common inelastic collision examples. The reason being is energy is not really conserved at the end of the collision. Now let us take an example that will make the vehicle crash the good relatable incident for inelastic collision. Now say there is a truck filled with loads, and the brake doesn't work and hits a lamp post that comes ahead. Now the energy with which the truck ran is not the same after the collision with the lamp post. So there is no energy conservation occurring in the process. Now that we know the energy is lost after the collision, it is instantly considered to be the inelastic collision. The momentum before the collision is conserved, but when it hits the post, it will have to decrease the force so that the vehicle stops right there due to brake failure. Now that friction is more, and the momentum will be less in the whole process. But we must also be aware of the fact that momentum has nothing to do with the collision process. Momentum is a quantity that will not be lost and always is conserved irrespective of the collision process. Clay models. We simply cannot generalize the clay model just like that to make it one example of inelastic collision. When any object made out of clay goes under collision will definitely lose its energy. When a simple pot is made out of clay and then is allowed to fall from a height, it will break certainly, and it is natural also. This for sure cannot be an elastic collision because there is a deformation occurring. Deformation always paves the path to a loss of energy that it had before it could collide with the ground. The moment it touches the ground, it loses the kinetic energy instantly. So what better way to show this as an example to indicate the inelastic collision example? Not just any random pot, but any other object, it will experience a force that will lead to the loss of energy in the process that it undergoes. Also, the non-conservation of energy and momentum in any process is nothing but inelastic collision. When clay ball collides in the air resistance will be friction in the air too. The energy will be lost whenever it faces resistance from the opposite side. The momentum of the ball in the air will not change until there is external force acting on it. Particle collision. Generally, particle collision is one of the common inelastic collision examples. The standard collision of any particle is always inelastic. Only a very few instances will lead it to the elastic collision. When the particles collide with each other or on a surface, they will undoubtedly lose the kinetic energy present in that particular particle. For example, let us say particle collision, surface collision, deformation of particle. All these instances are examples that show the inelastic collision process. And when the energy is lost in the particle, it will be considered to be the inelastic collision or simple partially elastic collision. Both mean the same but will differ under different scenarios. The particle collision not only tells about the end results of it, but also the loss of energy in the very same process. This leads to the deformation of the particle in contact with the process. And also, the surface erosion, breaking of the particle, is some of the end results of particle collision. The process will not hold any energy within because it will also be lost used by the particle. There will be no exchange of the energy within, hence leading to prove it as the inelastic collision. Falling objects. Generally, objects that fall to the ground due to gravity are said to have lost energy in the process. So inelastic collision comes into act. Whenever the object under collision sticks together, there is no energy conserved, and the momentum will be saved. Also, momentum, which is the amount of force that is to be acted upon the object, be less if the friction is minor. Friction is the factor that is present between the object under motion and in contact with the surface of motion. When this factor is responsible for the momentum change in a body, it will automatically reflect in the motion. Take any object for that case. Due to gravity, the object will fall and touch the ground. This event will decide whether the collision is elastic or inelastic. The energy before the object falls will undoubtedly change after the fall due to the hard hit. Now we know that since there is a loss of energy in the whole process, it is considered to be an example of inelastic collision. Also, momentum will surely be conserved as it is the quantity of force, and not any other deciding factor. Basically, all the falling objects will come under the category of inelastic collision since it loses energy in the process of hitting the ground. Clapping hands. Clapping hands is a known event for everyone. One might even say what big of an example it will be, but in simple acts does big things are known. When we join, both there is undoubtedly no energy lost as it exchanges, but when we clap them both, we hear a sound. This sound is nothing but kinetic energy getting converted into sound energy. Proper inelastic collision examples are the clapping hands, and are a common one too. From the studies, we have been aware that the loss of kinetic energy in a system during collision automatically comes out in the form of heat energy, sound energy, and sometimes frictional energy too. When there is loss of energy in such cases, we will have so many other facts, too, but the elastic collision and inelastic collision is one of the significant occurring that deals with kinetic energy. Sliding blocks. Idealizing the blocks to be of the same mass, and when it slides down a particular surface without friction, then it is said to be in an elastic collision. But this cannot be the case at all times, since we cannot say that the friction is absent. Friction will be present in all cases when a motion of a body is considered. Even the mass of the blocks has an influence on the collisions. When the mass of the blocks is the same, it will not affect the collision to be elastic or inelastic. But if the mass of one block is greater than the other block, there will surely be a significant influence on the energy and the momentum. So when the mass is higher, there will be a more incredible momentum, and due to zero friction, the momentum will be the same and be conserved at the same time. But the energy will be lost in the whole process of sliding. The reason being is that the blocks are sticking to the sliding surface and letting the energy be lost from the whole system. This is the main reason that the sliding blocks are considered to be one of the inelastic collision examples. Frequently asked questions. What is conserved in an inelastic collision? In an inelastic collision, momentum is the only quantity being conserved in the whole process. The reason behind this is that energy will be lost in several different forms. Energy will take forms at the time of emission because the rest of it will be used in the process alone. The amount of force applied for a motion in order to increase and be in phase with the change of speed. Due to less friction, the momentum will also be less, which in turn will be conserved in the whole system. What is a perfectly inelastic collision? A perfectly inelastic collision is a process in which not even the smallest of energy is left in the system. When the colliding bodies stick to each other very firmly, there will be a loss in energy, but if they become non-separable, the whole kinetic energy of the system is lost and cannot be taken back at all. For instance, a bullet hitting a bag of sand loses all of its kinetic energy in that process, and a man jumping instantly on a moving cart is one good example that says about perfectly inelastic collision. How does friction affect elastic and inelastic collisions? Friction is connected to the momentum of the isolated system, and it has a direct effect on the collision process. When there is zero friction in a system, the momentum will not change at all, because when the path is rough, the friction increases. When the path is smooth, the friction is minor. All of this is a significant contributor to the deciding factor for a collision process. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.